constant difference. So in theorem 5.7, it says when the differences between consecutive outputs in a table are the same, then the difference between consecutive inputs are the same, you can write the linear function for the table. So for this table, we're gonna first check to see if this has the same constant difference, and if so, then we are trying to write a linear function that fits this table. So let's look at the difference. So 1 plus what is 8? Well, 7. 8 plus what is 15? Oh, that's 7. 15 plus 7 is 22. So the difference between consecutive output, that means that these number has to be the same, right? That should have the same intervals, right? So it's the same difference. So if this is the case, then we can find the linear function. So linear function, we can write that as y equals ax plus b. That's one of the form that we can write. Or some people write mx plus b. So coefficient of x is going to be the slope, right? And the constant is going to be the y-intercept. Or, in other words, that's going to be the output for 0, right? So let's let's find the slope first, because this guarantees having the constant difference guarantees that we do have a linear function that fits this table. So let's find the slope. Slope is gonna be rise over run, right? Or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's pick two numbers, two pairs, right? 1 and 8 and 3 and 12, right? So it can be other pair if you want to, right? So let's do 22 minus 8, right? So let's call this is the second point and this is the first point, right? So 22 minus 8 over 3 minus 1, which is going to be 14 over 2, which is 7. So as you see, the slope is going to be the same as delta only if the table goes up by 1. So we got to be careful with that. So that's going to be A, right? B is going to be the output for 0. So what's the output for 0? F of 0, output for 0 is 1, so we're just going to plug back in. So the linear function that's going to fit to this table is going to be 7x plus b.